Okay, good. So the analytics lifecycle or the data lifecycle, as I was saying on the bring it, Abada, bring it. I can't wait to hear that question. Data, as I was saying earlier, data is the biggest problem in the AI in AI use cases because of its availability, its currency, its how current is the data. Which category does it transformers are different? That's all neural networks are about them. So if you look further down in that list, you'll see it's all neural networks, and it's doing the same thing. And then these transformers are all matrices and vectors, and it's all multiplication feed forward. So you can check it. So looking at the data, and this is a conversation that we had with several people on the academy, where they wanted to get into automation and automation with AI and data, and where do you get the data from? That's always the issue. So we already have seen it on a very small scale. There is an issue for an entrepreneur, a solopreneur, or a small business to deal with data. That only gets more amplified as you get larger and larger as an organization. And the first step is always in the data acquisition or the data collection, where you're getting the raw data that you want to be the foundation for your analysis. And the funny story here is from speaking about large enterprises, and I think Ken can attest to this. For large enterprises, you'll be surprised how difficult it is to actually get agreement on data collection or data acquisition from certain departments. People are very territorial about their systems and about the data. And something that, I was speaking to one of our engineers about it earlier today, and something that seems so trivial could actually take you weeks or months in a large multi-billion-dollar organization to actually get the agreement from one department to the other department for you to actually be able to do data acquisition or data collection. Anyway, just realize, based on the complexity of your business, even for a small business, you could find they have 3 or 4 different systems, and the data is really all over the place. So data collection is the first step. Now, once you have access to that data, or you import that data into whatever system that you're going to be building that model to train on, you have to do data preparation. So you have to cleanse and transform the data. And if you remember, there's a few that I rattle off from my head. Data currency, and I don't mean money. I mean, is the data current? Do you have Fadi's correct mobile number? And so that's data currency. Data consistency is Fadi's mobile number in 3 different systems. Is it the same or is it different? And how do I reconcile it? So data currency, data consistency, and data even availability. Sometimes you'll find gaps in the data between, all of a sudden we did this for Ministry of Health of a large country. And we were doing data modeling for 545 hospitals or something. And one of those hospitals, month of July, there was no data for the month of. I'm like, did something happen on the month of July? And they're like, no, we were operating and we had full capacity. I'm like, there's no data. We don't know what you guys did in the month of. There's no record of what you guys did for the month of July. So these are the types of problems that you get into that you don't expect when you start these projects. So I usually just take all our AI projects when we're doing data, anything that's with data, I multiply by 4. I think it's going to take me 2 weeks, I multiply by 4, it's going to take 8 weeks. And by the way, that turned out to be an understatement for that Ministry of Health, because it took 6 months for something that was supposed to take 2 weeks. That's just an example on, I'm not trying to discourage you. I'm just trying to give you a real world practical perspective from boots on the ground on what really happens. Based on your business and the stuff that you do, this might not be relevant, but you are still going to face some of these issues: data currency, data availability, data consistency. And actually, just in case you're reviewing this later, there are AI tools to help you bridge data gaps and extrapolate now, so that you can create continuation in the data stream, so you could actually build a model. Because the problem is that you'll have 12 months of data, there's 1 month that's missing. What do? You can fudge the data, or you could actually give it to AI and say, actually predict that month across these values, and it will fill that for you. You'll have to create a clone, of course, and then just say, now let's build a model based on that. Then you do the data analysis. You look at exploration, analysis, interpretation, to make sure that you can actually get some kind of meaningful model. Then you do modeling, predictive or descriptive models, using some of the techniques that we talked about earlier. For the focus of this micro session and this 1 hour, we're talking about linear regression. Then once you've done the model, you evaluate it for accuracy to make sure that it's reliable. And the way that we do this is we actually split the data set. So if we have, let's say, 1 million records, we take 80% of those records and we would use those to build the model. And then we leave 10% of the records where we test the model fitness for predicting values based on data it had not seen before. So this would be the 10% of the data that the model had never seen. And we look at that data and we say, we check the accuracy of the model. There are many different parameters, and there's something that's called the confusion matrix. And I don't want to confuse you right now, so just ignore it. There's actual ways by which you can measure the accuracy of your model. Look it up. But that's what goes on in evaluation. And once we test it with that 10%, if it's 85% or better probability, we move to use the last 10% that the model did not see by tweaking. And again, sorry for the techno geek speak, mathematics here. We apply higher level polynomials to see how quickly or how well we can increase the accuracy of the model. Can I nudge it from 86%, 86.5% to 89 or 90%? By the way, anything in machine learning or prediction, if you're 87% or more, you're golden. You're good. Let it rip. Take it to production, kind of a thing. But if you can get it into the 90s or better, then that's of course going to be very good. Deployment is when you actually integrate it into production. You put it out and you put it into a system that's going to face customers, that's going to make decisions. And then you look at feedback, where you collect the outcomes from the model, and you start. And this is also where confusion matrices come in to actually look at false positives, false negatives, things like that, to actually build a quad to show you where data, the prediction is lying across these 4 quadrants for the algorithm in production.